Manufacturing the specific optical glass requires the subtle control of refractive index and other various optical characteristics. For that purpose, more than 100 types of raw materials are utilized to achieve the optimum proportion and combination for each type of glass. This powder is the raw material used in EF 500mm f4L IS-USM optical lenses. It consists of materials such as quartzite and borax, and soda ash a submaterial. Impurities such as iron that cause reduced transmittance are removed to the order of parts per million, and each material is precisely measured and placed into the V-shaped mixer. The blended primary raw materials are placed into a platinum or quartz crucible and fused in a furnace under strict temperature and time control. This is molten glass. The glass is poured into a pallet in its ultra-high temperature state and allowed to cool naturally. As the naturally cooled glass is to be cast into a continuous fusion machine, it is crushed into pieces by hand once. To ensure optimum quality, the glass is cast into a continuous fusing machine. The glass is again melted at about 1300 degrees Celsius, mixed and churned, clarified and then homogenized. Having completed this process, the material becomes homogeneous liquid glass free of air bubbles. Poured into the shaping part, the liquid glass is shaped into a sheet. This sheet is gradually cooled to room temperature while traveling on a conveyor belt through a temperature gradient type continuous slow cooling furnace. The sheet glass produced by this process is used as the material for individual lenses. In high-quality optical glass production, the fusing and cooling processes are the most important. From each block of cooled glass, a test piece is cut out and both surfaces are polished for inspection. The test piece is then illuminated to check for defects. The glass is transferred to the shaping and pressing process after the quality inspection has been completed. Here, the glass is ground and pressed and formed into lenses. A variety of grinding machines and pressing machines are used depending upon the type of lens. Based on lens diameter, shape, and specific gravity, the necessary volume of glass weight is precisely calculated, and after cutting with a diamond cutter, is adjusted by units of 1/10 of a gram. Large aperture lenses used for EF 500mm f4L IS-USM are cut by hand using heat. In order to obtain even more precise weights, the cut glass undergoes various grinding processes depending upon its type. The glass is heated further and then formed into shape by pressing. Large aperture lenses used for EF 500mm f4L IS-USM are pressed by hand using expert techniques. automated pressing machines are used for small lenses. After going through these processes, the glass materials take on the shape of a lens for the first time. Although having the shape of an almost completed lens, pressed glass at this stage has intense internal thermal stress. To remove this stress, pressed glass is subjected to a process called annealing. First, the pressed glass is heated to 500 degrees Celsius in an electric furnace and then gradually allowed to cool. It is during this process that the internal stress is relieved and the precise adjustments of the refractive index are carried out. Due to resultant press marks on its surface, it is still not possible to focus images through the pressed lens after annealing. To remove these marks and to make the surface smooth, the lens is polished during the following lens machining process.